All right, I think we start. Good morning, good day, everyone. My name is Felix Reichenbach, and I welcome you to our webinar today, Turning Data into Business Intelligence, or Turning Data into Knowledge. And with me, I have Salim and Pedro, our two interns, who are excited to show you and demonstrate to you at the end of the presentation how our tools and solutions actually work. And let me hand it over to Choi, who's gonna do the first part of the presentation. Choi.
All right, thank you, Felix. Welcome, everybody. So today we're just gonna go through a brief introduction of the project. I'm gonna tell you about what we've been working on so far, sort of put it in context what we're trying to do. And then we'll talk a bit about data tiering, how that leads into data federation, and then obviously what we're all waiting for, the business intelligence and analytics part of all of this. So how we do that on data that you have in MongoDB. And as Felix said, I'll hand it over to Pedro and Salim to work you through some of those live demos to show you really what we've been able to accomplish. And at the end, we'll have time for questions and answers. So if you have any of those, please leave them in the Q&A box that you have at the bottom in Zoom, and we'll get to them at the end of the session. All right, so jumping in very quickly, some of you might know if you joined the last webinar, we're building a project that is based on an end-to-end four-step data integration framework. In the last session, we talked about how we collect data and stream it through Kafka from factory devices into MongoDB. And today we'll be dwelling on the compute stage, which is about processing this data and essentially building analytics to gain insights on top of that. So we're going to really start with an overview of the architecture of our project. What we have on the ground, we have our little model factory. It comes with an MQTT broker, so these are MQTT devices, and we're able to set up a remote MQTT broker that allows us to stream data through Kafka into the MongoDB data platform. And then from there, we built a couple of applications that help us to leverage this data and to improve processes on the production line. But sort of zooming into today's strategy, for analytics, we consider having different data sources, some from the sensors on the factory machines. We have enterprise data, inventory data, product data, all sorts really at an enterprise scale. And we bring that into the MongoDB data platform. Now, we have the option, if you're using a self-managed environment, to use the BI connectors to get started with analytics. On the other end, if you're looking for a cloud solution, we offer several options for data tiering, like the online archive, data lake, object stores, which then allow you to use the federated query API to connect to the preferred BI tool of your choice. So think Power BI, Tableau, Grafana, all of the good stuff that we probably already have going in our organizations. Now, I'm going to hand it over to Felix shortly, just to walk you through sort of data tiering, why are we trying to do it, and what the challenges and the options we have in this area are. Felix, over to you.
Thank you, Choi. I'm going to talk a little bit about workload isolations, because you likely have operational applications or operational workload, like I have it on the left slide here. And you have different people trying to analyze data which is produced. And likely they want to analyze data which has been produced recently. And MongoDB, with its distributed architecture, actually gives you a pretty cool architectural pattern which allow you to segregate data across different nodes and use the different nodes for different workloads. So as shown on my example, you likely have a MongoDB replica set, at least 3 nodes to maintain your high availability of your MongoDB cluster, to serve all your transactional operational workloads, to control your processes, to steer your processes. And then you can add, even when the cluster is already up and running, additional MongoDB nodes and dedicate them to different roles. Now, this is all plain MongoDB technology, and it works the same way in a self-managed environment, literally anywhere where you can run MongoDB, but also in MongoDB Atlas, our MongoDB as a service product in the cloud on AWS, Azure, and GCP. Now, these real-time analytical nodes, they usually have different query patterns. So OLTP is literally querying distinct documents, whereas BI or analytical workloads are more about give me, I don't know, the average of a distinct attribute. And these workload patterns also benefit a lot from different indices. And that's why we announced that MongoDB World, that we're going to introduce columnar indices on top of MongoDB data, which means you will literally be able to add additional secondaries, replica set members to your MongoDB cluster, dedicate them for data scientists or BI typical workloads, create additional or different columnar indices. So you can query data in MongoDB similar to a data warehouse, extremely efficient, calculating average of all the temperature sensor data within MongoDB, for example. The same on top of your MongoDB data, which is replicated in real time or in near real time. So literally you have real-time insights into what's happening right now, and you can run your calculations without affecting your operational workloads directly within MongoDB. There's a lot of SQL tools out there. So that's why we provide the BI connector, our SQL API. So you can literally connect literally any SQL capable tool to MongoDB. But more and more, there's also technologies, other companies who come up with native MongoDB plugins, such as Grafana. And we do also have MongoDB charts, which we're going to demonstrate today. OBDC connector is available as well. If you have a lot of calculations in spreadsheets, I've come across many of these. You can also extract data from MongoDB into a spreadsheet table and feed your calculations in the spreadsheet. For more data science or AI ML workloads, we do have a Spark connector. And obviously, you can use any MongoDB driver to connect directly to the nodes and query data directly from MongoDB. Now, this is not really data tiering. Some people use it for data tiering types of purposes. And by data tiering, I literally mean hot and cold data, optimizing storage and resource costs. And that's why we built MongoDB Atlas Online Archive. And MongoDB Atlas Online Archive is a solution which fully automatically removes cold data from your hot data storage. So you literally create data in MongoDB, traditional MongoDB nodes, super fast, low latency queries. And over time, data gets older, colder, and the latency requirements get a little more relaxed. And you can compromise on latency, low latency queries by storing data on cheaper storage. That's what MongoDB Online Archive does. It moves data from hot data tiers to S3 buckets today, so you can benefit of lower storage costs. It will maintain queryability. You can literally query the hot and the cold data together, and it's fully managed. So the only thing you have to do is literally configure these archiving rules. And you can also integrate it into the federated queries, which we're going to show you a little later today in the presentation, to enrich the data sets, combine it with other data sets, one of my favorite features within MongoDB Atlas. So on a little more detail, on top you see our MongoDB Atlas cluster where data gets produced, stored first, the low latency hot data tier. Then once this data tier or this cluster, these nodes grow and may get a little expensive, considering the old data in that store, you want to consider offloading the data. So all you have to do is configure an archiving rule, usually specified on a timestamp in the documents within the cluster. And MongoDB Atlas Online Archive will then go move that data into a file into S3 buckets, and then delete the data in the Atlas cluster. And through a federated API endpoint, you can then literally query the hot and the cold data tier, just like you are connected to a single MongoDB cluster. Slightly higher response times, we're likely talking seconds if you query S3 buckets, but for analytical BI types of workloads, that's still more than good enough. Now, storing a lot of files on S3, yes, it saves cost on the storage side of things. But as soon as you start querying it, it can actually get pretty expensive as well, because if you have to scan all the files on an S3 bucket, you just process a lot of data by potentially not getting a lot of insights out of it. And so since there's a lot of room for improvement, we created Atlas Data Lake. And why do you want to use Atlas Data Lake? Well, it's pretty cool. It has, it's optimized for high performance by using hierarchical columnar file formats for storage. And it uses a metadata store to store pre-calculated values. And that makes it a super economical large-scale data store, where you can store your old and cold data and still query it with the hot data. It works the same way as with Online Archive. as it's fully managed and integrated into MongoDB Atlas. So let's have a look at a little more detailed picture. So at the bottom left, we have our MongoDB Atlas Cloud Database cluster. Today, you can only connect a MongoDB Atlas cluster. In the near future, you will also be able to pull in data from any S3 bucket to leverage the optimized storage format and partition indexes. So data gets not pulled from a hot MongoDB Atlas cluster, but rather from a backup snapshot. So you're not affecting your operational workloads at all. We will literally go read your backup snapshot. We will analyze the data, pre-calculate values, count of measurements, average across specific measurements. We'll write these pre-calculated values into a metadata file, also stored on an object store on S3 today. And we'll then store the actual data in an analytical file format created by MongoDB to store it in a columnar format. So you can process your analytical queries much faster and much more efficient, because you will only read the columns you're interested in and not every time the whole document, which you would do within MongoDB without using the columnar indices, which we're adding to the database solution. So highly efficient. If you ask a question about an average value, which is stored in the partition index, you would actually not go into any data file, but you will literally get the answer straight out of the partition index. Kind of comparable to a covered query in MongoDB Atlas, where your query will be answered by just asking the index, which is likely already in memory and therefore super fast. We can even reach sub-millisecond response times in MongoDB itself. So that's Atlas Data Lake, a newer component within MongoDB, and I like it very much. And what I like the most, say it again, is Atlas Data Federation, and Joy is going to explain to you how that works in detail.
All right, thank you so much, Felix. This is also one of my favorites. So essentially, data federation allows us to liberate data from the complexity of data silos. So you're thinking about having data in from multiple sources and multiple stores, and you want to access them effectively. You want to run efficient queries, and you really want to be able to focus on differentiating work while you code. So it really breaks down that complexity because it allows you to get data. Imagine you have in your Atlas clusters, you've done some tiering. So you have your data in an online archive, you have some of it in a data lake, you have some in S3 buckets, or maybe just like an assortment of JSON files that you have hosted on the web. So you're allowed to essentially bring all of this together, and our federated database instance creates for you a virtual database that allows you to leverage really the full power of the aggregation pipeline and the federated queries. So you can move that data or work with it in another Atlas cluster, for example, or in your data lake, in your S3 buckets, where you can really get direct queries through your applications directly. Or you have the option of using, if you've already picked a favorite BI tool, let's say, for example, Power BI, you can then use the Atlas SQL interface to connect to that and start your data analytics processes. Another option would be to use Atlas charts, which we develop in-house. And we're going to be showing you a little bit about how that works. Now, all of this comes together with no additional ETL tooling, sort of all in one, right from your Atlas cluster. So imagine we have this federated instance. We brought all our data together. It's free. We sort of start to recommend as a first point, Atlas charts as sort of like the best way to visualize data that is already in MongoDB. Now, this is because it provides a fast, easy, and powerful way to start to build visualizations. It's obviously built specifically for the document model. You have it already in MongoDB Cloud. So by virtue of your access to Atlas, you have access to MongoDB charts, and you can start to create these quite interesting, quite compelling dashboards like we have here. We're going to show you a bit of a demo about how we get that using data that we have gathered from our own manufacturing production line factory model. Another option, if you've already decided that there's a tool that you love more, which that's all right, of course, if you already use Tableau for other processes and you're sort of looking for a way to bring the whole system together with minimal integration time and ease, the option I would propose in this situation would be the Atlas SQL interface. Now, what this is, again, you have your data in different places in different stores. You bring it together in your virtual database, and then you have the Atlas SQL interface, which essentially exposes the MongoDB query language, right? And this allows you to use various connectors, some that we develop in-house and others. So we have the Tableau connector, we have a Power BI connector, we have the JDBC and ODBC drivers. And this allows you to just connect to the tool of your choice directly from your virtual database. Now, this is really sort of the big part of the demo that we've prepared for you today. And that means it's right about time for me to hand this over to Pedro. Pedro, just let me know when you're ready and we're good to go. And it's all yours.
Hello, guys. Thank you, Joy, for the introduction. Yeah, as Joy said, today I'll be demoing data federation and charts. So basically, MongoDB Atlas already comes with many different features, such as data federation. In this case, we're going to create a federated instance and basically add different data sources and also integrate this instance into charts and actually get some analytics and some data visualization. So let's just dive right in. So as you can see right now, I'm on the Atlas homepage. As you can see, I have a cluster already running, my IoT backend. And on the left-hand side, you can see data federation. This is a feature that it's already pre-built into Atlas. So we have to click it and start playing around with it. We have already created some instances, but we are going to actually show, I'm going to actually show you how to create a new one and actually how easy it is and all the steps you have to follow. So basically here on the right-hand side, you can see create a federated database. It's as easy as clicking the button. And here you can actually change the name. For example, it already creates a database and a collection, but you can actually delete this one and create a new one, rename it, and or even add many databases and collections. And to create a database, it's as easy as clicking the button, and a collection for each one, it's as clicking the button here. It already comes with different data sources, so it's just as simple as hitting add a data source, and it comes with already different options. In this case, we have S3, which lets us maps data into S3 buckets, allowing us to actually get the data from the S3 bucket and actually integrate it into our collection. This is mostly used for cheap storage and also cold storage. We also have our Atlas cluster, which lets us integrate every cluster running that we have, containing most of the time hot data, and allowing us to basically combine different clusters together. And lastly, we have HTTP and HTTPS, which lets us actually get a URL that points to a certain file. In this case, has to be of a certain file type, such as JSON, BSON, CSV, or others, and we can actually integrate it also into our instance. I have already done the whole configuration, so we don't waste a lot of time in adding different data sources. So I'm just show you the configuration I have already done. So it's this one. This is the instance we created, and I'm gonna just show you the configuration. So we have been playing around with already creating some databases, but I'm gonna just collapse that because we're not gonna use that one right now. We're gonna actually create a new one. So as you can see, as I told you before, we have the different data sources. We have HTTP, we have Atlas cluster, and S3 buckets. So this is pretty cool because we can actually integrate them all together into one collection. So let's actually do that. We can actually create a new database, as I showed you before, and let's call it webinar. And our collection name could be demo, for example. And we hit create. And now it's pretty easy because we see it's here, webinar and demo. So the database name is webinar and the collection name is demo. And it's as easy as just grabbing, for example, I like this data source, just grab it here. You see it, this one is a HTTPS, it's a URL, and you see it points to a JSON file, which is basically more censored data. As Joy said, it's most of the data, well, all of the data is basically from the smart factory and how it collected this data and how it got moved to different storages. So as we can see, we can also add, for example, the cluster, which basically contains the most recent data, or in other words, hot data. And lastly, we can add, for example, the S3 bucket, which basically it's more old data or archive data that's not useful for us right now. So actually, then we can just hit save, and this will actually create the federated collection, the virtual collection inside our instance. So same with, we can do it with a cluster, we can do with an instance. So we can actually connect. As you can see, it has all the options, same as a cluster. You can use the shell, you can use Compass, you can use the VS Code extension, and more. In this case, we're going to use Compass because it's GUI for Atlas, and it's pretty handy. So you pick your version and you actually just grab the connection string, change your username and password, and paste it into Compass. I've already done this, so you don't see my password. but I will just switch screens and show you in Compass. So basically, we see here that I have already connected to my IoT backend, and this is the Smart Factory Federated database. So we see I just pasted the connection string, I put my password, my username and password, and we hit connect. So now if everything worked properly, a collection should appear, as we can see, a database should appear, as we can see here, called webinar, and a collection called demo. In this case, this is just the merge of the S3, the Atlas cluster, and the HTTPS all into one collection, which is pretty neat and pretty cool, if you ask me. As you can see, we have 27,000 documents, which it's a lot of documents, and it's all of this is data from the Smart Factory that was collected in different periods of time and in different places. So actually, we can not only view this data in one collection, but we can actually integrate this collection into charts. So I'm gonna just hop back into Atlas and show you how easy it is. We can see that we have the option to go to charts. And as we already know, charts is basically a BI tool already built into Atlas. So it's really easy to just grab a MongoDB instance and actually add it as a data source and create some data visualization charts. So first things first, we have to add the new data source we just created. It's pretty easy. You just grab, you go to add data source, and it's gonna already be there. It's gonna tell you what instance you want to add. So in my case, it's Smart Factory Federated database, which is basically the instance that we created with the webinar data. And we just have to wait for the connection to go through. And it's gonna now allow us to decide which database we wanna use and which exact collection we wanna use. In our case, I'm gonna use the one we just created, which is webinar, and the collection name is demo. So I'm gonna just integrate the whole database because there's only one collection, so it doesn't really affect anything. And as you can see there, it appears at the top. We have a few seconds ago, it just added our new data source. So if we hop back into dashboards, we can actually, as you already are familiar with charts, add a new dashboard and actually start playing around with the data we have in our collection. So for example, we hit webinar demo and we can add our first chart. And first things first, we have to add our data source, which in this case is the one we just added, which is webinar demo. And it's now sampling the data, as you can see, which is it's just sampling some documents and getting some fields. So as we see, it appears here. You also have the chart types, and you just have to drag and drop each field into the axis you want. In this case, is, as we mentioned, data from the Smart Factory. So it's sensor data, which basically, for example, H is for humidity, P for pressure, T for temperature, and so on. As you can see with a TS, we can actually, first things first, I'm gonna change the chart type. I'm gonna put a line, and I actually can grab the TS and just drag and drop into the X-axis. And then I can actually grab whatever other field I want to show. So I want to show humidity, for example. And then a chart is going to be made. So here we can see, but we can actually change to our desired configuration because we're using time series data. We can actually filter by minutes, so it's easier. And we have a more precise data. And also, instead of sum, we want to use the mean, for example. And we should get a chart that shows data from a long period of time and how the humidity has changed over that period of time, integrating the whole virtual collection that contains data from recent days, but also data from other months ago. And we can also add, for example, a name, in this case, title, sorry. In this case, we can give it humidity over time. And we could also add a description, in this case, demo. And we can actually save and close. And just like that, we added the chart to our dashboard, and we just created a chart with virtual data containing different data sources that it's allowing us to actually see data from different periods of time, which is pretty cool, in my opinion. We can not only do this, but we can actually also share, if we want to share this dashboard with anyone. In my case, I can actually share it with my whole team, for example, everyone in Industry Solutions, and I have to grant access to our collection. So I'm gonna do that. So now anyone in the team can actually access this dashboard and see how things are going. But I also can create a public link, as you can see on top, and I can just enable this option, and anyone with a link can actually access this dashboard and see things. It's pretty cool also because it refreshes in real time and has a lot of benefits. And just like that, we created our chart using the virtual instances. Now I'm gonna hand it over to Salim, who's gonna use the same instance that we created, but actually create the same chart using other BI tools such as Tableau, third-party BI tools such as Tableau, Power BI, and Click. So over to you, Salim.
Perfect, thanks. As Pedro mentioned beforehand, what happens if charts doesn't cover all your needs, or you simply prefer using your beloved visualization tool? Well, no worries, because MongoDB has you covered, because it offers simple integration tools with popular visualization tools like Tableau, which we are going to demo right now. We simply head over to Data Federation, then go to Connect. And here we can see the option Connect using the Atlas SQL interface, which we're going to click on. And this is all the information we need to establish the connection. It's important to mention that for us to connect a federated database, we have to do some configuration beforehand, but we've already done that before. And it's simply just installing a couple of libraries into the Tableau folder. And you can read more about it in the information below, in the docs below. But we've already done that, so let's go ahead to Tableau and establish the connection. So now we're in Tableau. Let's head over to Server, More, and here we have it. This is the new connection that we've created using the library that we've installed in the Tableau folder, and the one below it is the one that's already available for us in Tableau to connect to your average Atlas clusters. So we're going to move ahead with the option above. Let's click it. Okay, so this is the link that we had in the information. We just copy it and pasted it. I've done that beforehand. We've put the name of the database that you want to connect to that Pedro created, and then you put your username and MongoDB password. So let's go ahead and do that. And let's sign in. Awesome. So we have a connection. Here at your left, you can see the table that Pedro has created, demo, and here you can see all the fields that it has. And we're going to try and recreate the stem chart that we created using MongoDB charts. So let's go ahead and head over to Sheet down here. Let's remove this and do it again. Remove. Awesome. So let's head to TS. In stream. We have it already in line. So let's copy over the humidity. Change it to average. Move TS over here. Awesome. There it is. The exact same chart that we created in charts. Let's go ahead and compare it. If we head over to chart, so we can test like the viewing privileges. Let's head over here, and we will see it in charts. There it is. Awesome. Perfect. So that's the demo. Hope we were able to showcase the main mission statement for the webinar, which is to manage your entire data lifecycle using a consistent set of tools in MongoDB Atlas, be it federated queries or any of the other technologies that we showcased. Let's head over with some questions. Back to you, Felix.
Thanks, everyone. And please add some silent applause into the chat window to our amazing interns. I think they've done a great job today. And of course, Joy as well, as usual. We're now here. Feel free to use your cameras, take a screenshot and type in the links if you like to get a little more information around these topics. And if you have any questions, please add them to the chat window. If not, I hope you have a great day, and I also hope to see you soon at one of our events or on our next webinar, which we still have to schedule. So check your mailbox. You will likely get a notification once it's due.
So sorry, just before you leave, if you can just take a few minutes to answer our poll. I'm just going to launch it now. This poll just helps us with creating content for future webinars. So if you can just take a few seconds to answer it, that would be great. And as Felix said, if you have any questions in the meantime, just let us know in the chat section or the Q&A section. Thank you.
Right on time.
Exactly. I'm just going to leave it up for about 2 minutes, and then we can just say goodbye to everyone. Thanks.
Perfect. Thank you very much. So it seems your explanations were excellent. No questions. I think the solutions are pretty easy to use, pretty straightforward as well. And that's one of the reasons why I like them, especially the federated query API. Just going to stay for a few more minutes. And if you have suggestions for other topics, please feel free to send me and the team an email, felix@mongodb.com. Specific areas of interest. We're always trying to figure out what people would like to see. If you have something you would like to see, let us know, and we'll try to add that to our content.
Right, we have one question, just one in the chat from Lawrence. And oh, I don't know if this is a Lawrence he or Lawrence she or Lawrence they. So I'm just going to say, they asked, does Atlas ever move data back to the hot tier from the cloud if it is requested excessively, for instance?
So great question. You can move data back into the hot tier through the federated query API. So as Joy mentioned on her slide, if you use the federated API, you query data across hot and cold data, or just from cold or data in S3. You can do a $out back into either another S3 bucket or into a MongoDB Atlas cluster and bring data back into the hot tier. Now, by today, this is something you would have to take care of. There's no automated workflow or sophisticated algorithm figuring out what data to bring back from the cold store into the hot store yet. But it's definitely an interesting feature. So hope we're going to see that in the future.
Right. Thank you, Felix. We have one more from William. And he asked, if you had a more detailed explanation of the process of backup in Atlas with data tiering. So I guess this means for the data lake, where we use backup snapshots. If we could just talk a bit more about how that backup works in the data lake.
So the backup process in MongoDB Atlas basically creates backup snapshots and moves these backup snapshots into, depending on the cloud provider, into the specific object source. So on AWS, it's S3. On Azure, it's the similar thing on Azure, and on GCP, exactly the same thing. And Atlas Data Lake is just going there and taking that backup snapshot file, scan through it, extract the data, and move it into Atlas Data Lake. And you have a few options to configure what data you would actually want to extract out of that backup snapshot. And the good thing is it doesn't affect your performance because it's not querying any of the actual Atlas clusters. The downside, if that could even be considered a downside, is that it's not live data. So depending on your snapshot schedule, it may be a few hours old, but that's likely more than good enough for your specific analytical requirements. I hope that answers the questions. If not, feel free to add some more context into the code, into the chat, sorry, code.
Right. Thank you so much, Felix. We have a couple more just popping up. I'm happy we're getting these out there right now before we run away. Christopher asks, do charts do what time series databases can do with respect to visualizing data in real time? So this is basically dealing with Atlas charts, but with time series data specifically. And
so first of all, real time is a terminology which needs to be articulate a little more precise. So we're not in the microsecond real-time space, but we're definitely in the millisecond real-time space.
Soft real time, yes.
Yeah, or soft real-time, how some people call it. And we can definitely analyze data within milliseconds, also run complex queries on top of that data. And now if you process a lot more data, you will likely end up with slightly higher latency requirements. If you parse the whole data set, you may end up with a 1 second response time to get that calculated result. Now for time series data, and I think we explained that in the last webinar, we use already a specific columnar storage type. So we optimize time series data for analytical queries, and we also benefit by super high compression rates, way over 90%. So that's what our time series collections do. And so this part is already highly optimized for the needs around querying, working with time series data.
Perfect. Yes. Oh, we have a couple more. How would the connection be with Power BI? Okay, so Kieran says, I didn't see that option in the selection, only JDBC and Tableau. So I would just take this one. So basically, a lot of these connectors are in development. So they are being sort of released, should I say, sequentially. So those will be made available shortly. There will probably be some sort of announcement when the Power BI connector is ready. But so we're sort of giving you the list of those that we're working on right now. So it will be, you know, I'm sure there will also be opportunities to try this out soon in Atlas. But yeah, definitely something to look out for. Yes.
Joy, do we have, I don't remember, but feel free to reach out to me. Let me type my email in the chat window. .com, I hope it's right. Because I think we actually started the early access program for the Power BI connector. So if that's something which is burning hot for you, reach out and I'll get you connected with the right people.
Right. Okay, great. So you'll be getting the inside scoop, Kieran. Let me know how that goes. Crystal has another question. If you need to run your MongoDB database on-prem at a customer, can you still make use of charts without storing the data in Atlas? Should I break the bad news? Okay, go for it.
I know this was possible in the past. We then decided to bring Atlas and MongoDB charts or make it only available in the cloud to accelerate basically development process of MongoDB charts. So by today, MongoDB charts is only available in the cloud. If that's gonna become available for on-prem, usually heavily depends on the customer requirements. If we see a strong trend for people asking for MongoDB charts to become available in self-managed environments, then that's likely what we're going to do. So feel free to let us or your account team know about these specific needs, but today this is not possible, unfortunately.
Yeah, so for on-prem, you would have to defer to the BI connectors, which are natively developed by MongoDB, and you can go ahead and use those to connect to any other BI tool that you might be interested in using. So we're gonna stick around for a couple more. I see you guys are just coming out of the weeds now, so this is great. If there's, oh wait, we have Fui, I'm gonna say it's Fui Chan, says, is there a way to further slice the data from the federated data like row level security? No, I'm not reading this correctly. Is there a way to further slice the data from federated data, like row level security? Felix, does this mean something?
Let me just quickly think about it. Further slice data from federated data, like.
I'm so sorry, Fui. I'm probably just not reading this right. So if you have a way of like clarifying the question, it would be great if you're still in the chat. And we can.
No. So there's a few options. So we have very fine or finest granular access possibilities using Atlas App Services, where we can literally specify access to specific fields. Now, if that works with the federated API, I actually do not know. But what works for sure is if you create kind of views and give access to views, and in the views you only project the fields which are meant to be available to that specific role, you can actually do that way. So create a view, add the fields to that view. You can materialize it, or you keep it just as a single view, and then that will be exposed. Only the fields will be exposed to that specific person accessing that view. So that is usually the way people work around this.
Right. Okay, and you have a thumbs up from Pui, so that's great. Okay. Sorry if I'm fading out. I feel like the sun is eating me up. I'm sitting in front of the window. It was a good idea at first, but now I'm being consumed by the light. But if there is anything else, we'll just go ahead and take that, and so we can wrap up in the next 2 minutes, guys. Remember, so the links you have on your screen will take you to previous content around this series. So we sort of built all the work we're doing into an IoT blog series that goes from the first step of the framework all the way to the end. You can see the last webinar we did about streaming data through Kafka from the factory to MongoDB. You also have access to all of our source code in this project on our Smart Factory GitHub. And yeah, let us know. You can contact us industry.solutions@mongodb.com. I will leave that in the chat for any other questions. And it's been a pleasure having you.
Great. Thanks, everyone. Have a great day, great rest of the week, and hope to see you soon.
Great. Thank you, guys. Bye.